Yes, Gatika, now it is. All right. So at A, what's going to happen is that the weight of the object is going to be down, and the centripetal force, as you guys know now, always acts, towards the center. So the centripetal force is being provided by the reaction force from the track onto the cart like this, right? And so we can say that at A, centripetal force, which is the resultant force, Fc, has to be R minus W. Now, the reason why R is greater than W, because it is supporting centripetal force, right? It's providing centripetal force, so we need to understand that it has to be resultant upwards like that, right? Then okay, so we can actually would like to find the R. So R then can be written as Fc plus W. So centripetal force is mv squared over R, and W is mg. So that's what R is going to be. So you can just make the equation according to you, whatever you need at that time. The other part which is important is when the car is like upside down on the track like this. So obviously the weight of the car is going to act downwards. And with that, we should also understand that the centripetal force will also be down. All right. If centripetal force is down, whatever is left, the reaction force will also be down. Now, so what we need to understand is that at C, then Fc, which is the centripetal force, should be equal to W plus R, because both of them are acting at the same point. Is that clear, everyone?
Yes, sir.
So if I need to find R, then it's going to be Fc minus W. And then R can be found out as mv squared over R minus mg. So obviously the reaction will be lowest. That's why when anything, goes upwards, right? So when you're like in a swing or something that goes like 360 degrees, so the most fun you have is when it goes at point C, because at that time you feel like you're weightless, right? And that's something you enjoy, and that's because you do not feel reaction, or the reaction on your body is very small, right? However, on B and C, what's going to happen is if the car is here or the car is here, whether it's climbing or it's like descending, in both the cases, you need to understand that the reaction is going to be here. And that's what basically provides centripetal force, really. But the weight just stays the same. Weight has to be down all the time, no matter what. So weight doesn't really play anything. And so we can say that at D and B, the centripetal force has to be equal to the reaction force. So you can just find reaction as mv squared over R. That's it. So they won't be even concerned about B and D normally. So you need to remember that. However, in a case where, let's add on another point, which I never did previously. Let's call this VCTE. And that's when the car is somewhere here. Okay. If the car is here, then you need to understand that the reaction is going to be here because of, it's always 90 degrees to the track. And because of the reaction, centripetal force is going to act, right? Like that. But the weight, like I said, will be down as it is. Okay, like that. Now, interestingly, at E, we need to understand that obviously there will be two components of the weight. So one component is going to be like this, the other component is going to be like this. If this is the angle theta, right, at which it is, then this is going to be W sine of theta, and this is going to be W cosine of theta, like that. Okay. Now, what you want to do is you should understand that we are only looking at this. Oh my God. We are only looking at this particular line. Okay, we're not interested in W cos theta because W cos theta is helping the car to move down, right? So what you're going to do is you're going to write that at E. So at E, we can say that FC will be equal to R minus W sine theta. And the reason why R is again greater than W sine theta is because the centripetal force has to be towards the center. And now to find R, we would write it as FC plus W sine theta. FC is mv square over R, and it is mg sine of theta, right? That. So this is how you will include sine in a case where it is at a certain angle. All right, is that clear, everyone?
Yes, sir.
Now, usually what they do is they say a question usually comes where they say that comparing A and C, which point would have the greatest tangential velocity. Okay, so what you guys need to remember is that number one, okay, the speed will be greatest at point A, first of all. Centripetal force is equal to mv square over R, as you know, since reaction is greatest since the reaction is greatest, the okay, I wanted to write the anyway. Since the reaction is greatest, hence a greater centripetal force is required, right? So this is what we talked about point A. All right. Now, so V, which is the speed, must be the greatest, because if you see the centripetal force depends on the speed, like that. That's why. The other reasoning for this is that because if you're moving, you should understand that at C it will have the greatest gravitational potential energy. So here it will have gravitational potential energy greater than kinetic energy. And here at this point, you will have kinetic energy greater than gravitational potential energy, because when you go up, you lose velocity into gravitational potential energy, and when you come back, it basically converts to kinetic back. Is that clear, everyone?
Yes, sir.
So both would be valid reasons if you want to just write it down. Okay. Now, okay. So Nadia, everything is clear. Ahmed and Munib.
Yes, sir.
Now, so please write this down on your. I hope you guys have printed the material out. Okay. And you're writing along with me. Okay. Now,
Oh, sir.
yes.
In the
Yes.
question in point 2, what's the fourth word from the left?
Point two. What is point two?
No,
Oh,
in the question, in the answers
okay.
point 2, what's the fourth word?
Since reaction is greatest, hence a
Oh,
greater
reaction. Okay.
force. Okay. All right. It looks like nens, but chalo, I'll do it hence. Okay. Now, so going to the question. Now, this question says what is meant by centripetal acceleration. Have you that? Okay. All right. All right. Okay. So, okay. All right. So now, please, let's do the question. And in the question it says, what is centripetal acceleration? So, centripetal acceleration, for just 1 mark, you just need to remember that it is acceleration that is always perpendicular. Okay, so writing perpendicular is essential because it's something that defines circular motion acceleration. So acceleration that is always perpendicular to the tangential velocity. You can just get away with writing velocity as well. That's fine. Because you just need to remember that when something's moving in a circle, so if the velocity is like this, the acceleration is always towards 90 degrees, right? If the velocity is like this, still the acceleration will be like this. So it will always be 90 degrees towards. Is that clear?
Yes, sir.
All right. Then it says an unpowered car moves freely along a smooth track that's initially horizontal. The track contains a vertical loop around which. So the moment I see this, I know it's a vertical question, right? Now it says the mass of the car is 230 grams. The diameter of loop is,
Sir, एक second, move up further, please.
yeah, yes, please.
Yeah, okay.
All right. So it says state what happens to the magnitude of centripetal acceleration of the car as it moves around the loop x to y. Okay, so we just need to see this now. Now this question that I've just, it has the same answer as this one. You see, because you see the speed at which at c it is going to be the lowest, right? If the speed is lowest, then the centripetal force is going to be less. And if the resultant force becomes less, what do you think will happen? The acceleration will also reduce, right? Is that clear?
So, sir, the magnitude will be less.
Yeah. So it will basically decrease, right? So it decreases. So basically, this highest centripetal force will be here and the lowest will be here. The reason is because the speed is reducing, and as the speed is reducing, because F is equal to mv square over r, as v is reducing, and obviously F is going to reduce. Understood?
Yes, sir.
Okay. Now it says explain if the car remains in contact with the track, why the centripetal acceleration of the car point wave must be greater than 9.8. Now you should understand, if you go back into the question, here we should understand that basically there will be weight of the car acting and there will be the reaction force, right? The centripetal force is weight plus the reaction in this case, because this is case C, right? And the reaction force is basically FC minus W, right? Now check this. If I say that FC is mv square over r and this is mg, if this force becomes smaller, if mv square over r becomes smaller than mg, what will happen then? The reaction, or even if it's equal, right? The reaction will be zero. So it will basically fall from there. Do you understand what I'm saying?
Sir,
So,
can you repeat the ending? Like how?
okay, let me rephrase it. Suppose if I write it like this, if centripetal force and the weight is being subtracted by centripetal force at point y, right? This is y. Understood? Now,
Yes, sir.
if W is equal to FC, right? Then the reaction, the people that are inside or the car will feel weightless. Do you understand? Because it will feel no reaction. Because if let's suppose FC is 5 newtons and weight is also 5 newtons, the reaction will be zero. Do you understand? So in order to feel the reaction, the centripetal force, if it's 6 newtons, then it's 5 newtons, then there will be 1 Newton reaction, right? If FC becomes less than W, then what happens? It will basically, the car will fall down. Do you understand? Because then the acceleration of gravity is going to be greater than centripetal acceleration. Do you understand what I'm saying?
Yes, sir. Now I do.
Okay. So now how would I approach this question? I would write that 9.81 meters per second square is the acceleration due to gravity, right? Caused by weight of car. So this would be my first point, okay? The second point I would write would be that, so centripetal acceleration slash, you can write force, must be greater than 9.8 meters per second square slash, if you're writing force, then you should write weight, to stay in contact. Do you guys understand this? Otherwise, reaction will become zero. Understood? So to keep something in contact, you need to move it faster. Okay. Yes. Mokshit and Munib and Nadia and Sman, do you guys understand? Aman, Ahmed squares, and
Yes, sir.
Anu. Okay.
Yes, sir.
Yeah.
Palak, everything is clear now. So this is what I just wanted to, explain to you. This is why this question is so important. All right, and you should write it down very clearly. This will help you out there. Anyway, now in the next question, it says the initial speed of the car in B moves along the track is 3.8 meters per second. Determine whether the car is in contact with the track at point Y. Now we need to do this, right? So first of all, we should understand the mass of car is this. We need to see whether they stay in contact. So our equation is R equals to FC minus W. And now let's put in R values. So mv square over R minus mg. And we need to see if R is basically still there, it's in contact or not. So this is the question really. So it's very simple. Put in the values. The mass is 0.23. We need to change 230 grams into kgs. The speed is given as 3.8 whole squared divided by, now the diameter is 62, so the radius is going to be 31. So we can write it as 0.31. You need to change it into meters. Minus 0.23 times 9.81. Is that clear, everyone? Now let's pull up the calculator. Let's see what you get. 0.23 times 3.8 square divided by 0.31 and minus 0.23 times 9.81. If you see, your answer comes out to be R, the reaction force comes out to be 8.46 newtons, right? So it stays in contact. If the reaction was 0, it would not stay in contact. Do you guys understand this?
Yes, sir. So, like, as long as there's some kind of acceleration, the car will still go on track.
If the acceleration due to centripetal force is greater, then obviously it's going to stay on track. That's what's going to
Okay.
happen, right? But yeah, so centripetal force is yeah. Okay, so this is why it's so important that you do this. But why it is 0.23 times 3.8? I've done this question a couple of
सर
times.
इसका आंसर नॉट इन कांटेक्ट होना चाहिए ना
Mhm. Not in contact ही होना चाहिए because the speed seems like less. It's
सर लास्ट
230.
टाइम we did half mx half mv
Yeah.
x square is equal to half mx square plus mgh.
Yeah. I remember that. But the thing is that we do not have. This says that the initial speed is this. Oh my God, sorry. It means that the speed initially is 3.8. We don't know what the speed is. First, we should find the speed at this point. Sorry.
Yeah.
Let's do that. Sorry. We have the same equation. Let's keep it here. Let's find the speed at here. So to go from this at this point, it has a speed of 3.8 meters. This is not very simple. I thought it was very simple. And then go up. This is going to be from here to here. The height is also 62 centimeters. The reason is that that's height. So first of all, let's find the speed. Can we say mgh equals to half mv squared? That's how we're gonna, find the speed. M and M cancels out. This is 9.81. Height is 0.62. Half times v squared. All right, but it has speed before as well, right? It has speed before as well. Wait. So that means that this is exactly not right. Wait. So it goes into mgh and then it is half m. The speed at x, v1, v initial squared minus half m v final. So yeah. Okay, now we'll do it. So m will cancel out. This is 9.81 times 0.62, and that's going to be half. The initial speed was 3.8 whole square minus half, and this is what we need to find actually. Okay, let's try this now. So this is going to be 9.81 times 0.62, and then this is 6.0822. This is going to be 0.5 times 3.8 whole square, 72.2
सर आपने
minus
0.5 लिखा है 0.5.
okay, sorry, 0.5 times 3.8 square, right? Okay, and this will be 7.22, and this is half vf square. Okay, let's do this now. So what you're gonna do is 7.22 minus 6.0822. So this is going to be half vf squared equals to 1.1378, and vf squared is going to be this times 2 under root. Okay, now we can do this. Multiply by 2 under root of answer. So the speed at that point is going to be only 1.51 meters per second. Now we have to check it with the equation. That's why it is like, oh my God, tough question. Okay, mv square over r minus mg. Now 0.23. And now the speed is 1.51 whole square divided by R is definitely 0.31 times 0.23 times 9.8. Okay, fine. Now let's do that. So then it's gonna be 0.23 times 1.51 square divided by 0.31, and oopsie, minus, it should be minus 0.23 times 9.81. Now,
Sir?
yes, the answer is minus 0.56. Yes. Now, because the reaction is in minus, it means it will not stay in contact. Yes. The reason, because FC is now less than the weight. Yes. Yes, please.
So you found the speed at which point?
At the height. That's the Y. At
A
Y.
Y, right?
Yeah. So basically, if you're confused about how did I get this equation, right, that I made. So I'll tell you why.
Yeah.
This is basically gravitational potential energy that was gained, right? Okay. Should be equal to the kinetic energy initial minus the kinetic energy that was left, that is final. Do you get my point?
Yeah, sir.
So you can also write it like this, like the kinetic energy, it had initially the kinetic energy. So kinetic energy is initial is equal to gravitational potential energy and the kinetic energy final, because that's at the end, it was like this. Do you understand? It would give you the same answer.
Okay. All right.
And
Sir.
then check whether R is equal or less than zero. So if R is zero and less, it means that it did not stay in contact. Understood? Because centripetal force is lesser than weight.
Okay, sir. Got it.
All right. Anybody who could not understand this, please let me know. I can explain it again. Okay. Suman, Nadia, and Gatika, Palak, Anusha, Ahmed Squares, and who's left? Munib and Mokshit, and Anusha. Yes.
Yes, sir, got it.
So I don't
Yes,
get
sir,
why it does
I
not stay in
understand.
contact.
Because you need to understand that for something to stay in contact, FC, the centripetal force, must be greater than weight, or at least be equal. Do you understand?
Okay.
Right now, if you look at this, like if I do it separately, you see this part of the equation, which is FC. Let me do it this way. Okay. Centripetal force is mv square over r. So when you do 0.23 and 1.51 whole square over 0.31, Gatika, it is going to be equal to 1.69 newtons, right? And now if you find the weight, if you find the weight, which is equal to mg, so it is going to be 0.323 times 9.81. So it is 2.25 or 2.26, right, Gatika?
Yes, sir.
Then centripetal force is less than weight, so obviously it cannot stay in contact.
Got it.
All right, for contact, you should have at least this as 0 or greater. Do you understand?
Yes, sir, got it.
Okay. Then it says suggest with a reason without calculation whether your conclusion would be different for a car of mass 430 moving with the same initial speed. Yes. Do you guys think it would be the same or different? I don't think so. It will be the same. It will be the same. The reason is that both in FC, it is mv square over r, and for weight, it is mg. So mass on both of them influence with just one factor, like it's just mass. So even if you cancel it out, it doesn't really matter, right? Do you understand? That's fine. So we could say mass cancels out. So it would not make any difference, whether the car is of larger mass or smaller mass. Okay. All right, cool. Yes, anything you would like to ask, please go ahead. Okay, then. Now, let's move to the next part. Okay, who's gonna tell me the definition of radian? Angle? Yes, go
Subtended
ahead.
at the center by an arc equal to the radius.
Angle subtended at center, that's 1 mark, and
By
the
an arc equal in length to the radius of the circle.
arc length is equal to radius of circle. All right, so this would be the definition. You should remember all the time this definition is there. Now it says why one complete revolution is equivalent to angular displacement of 2 pi radians. Okay. Anybody knows? That's not fair. So you should remember that S arc length is given by r times theta, right? So a complete revolution is equal to 2 pi radians. Do you guys understand this? Hence, we would say that theta, right? Theta, if you do like the complete circle is 2 pi r, right? And then you divide by r because the arc length is 2 pi r, that's the circumference. So this is going to be equal to 2 pi. Do you guys understand this? We can say one complete revolution is 2 pi r arc length. All right. Okay. Now this is pretty easy. You can just write it down. Now, next thing is this question. Okay, I really like this question anyway. So it says that a cord and mass are now made. So basically, it says an elastic cord has an unextended length of 13. So its original length is, let's call this LO. And attached to point C, small mass of 5 newtons is hung, and the cord extends to this. This is basically the final length. Okay, this one. So we know that the extension in this cord would be final length minus the initial length. So it is going to be 1.8 centimeter. Everybody agrees to this? All right, now look at this. Now it says the cord and mass are now made to rotate at constant angular speed omega in vertical plane, and the length is unextended. Now here it says the length was unextended, okay, at point C. Now when the mass was here, why would the length be unextended? Any ideas you guys have? So first of all, we'll try to make the equations here. First of all, you should understand that the weight of this is going to act downwards. So is the centripetal force. And because this is a string, so now there will be tension and not the reaction with tension there. So the equation is going to be centripetal force will be equal to tension plus weight. Everybody agrees? Now, how is it possible that tension, if I make this as this, how is it possible that the length is now unextended? It means that at this point, tension must be equal to 0. And how could tension be equal to 0 when centripetal force is equal to weight? Do you guys understand this? Now, please understand that tension causes things to extend, right? If nothing is pulling the string, so now it has come back to its original length, which was 13. It means the tension was 0. And at this point, we should understand that the only way tension could be 0 is when these two are equal. So they cancel out each other. So this is the point you need to understand. All right. Ahmed, do you understand? Both of you? And
Yeah.
Aman? Okay, now it says show that the angular speed, and it says that when it reaches this point in figure 1.3, that's when it's like fully extended. So it says show that the angular speed is 8.7 radians. Okay, I think we can do that. Now, what you guys need to understand is that because from this part, we understood that mr omega square, which is the centripetal force formula, is equal to mg. So mass and mass cancels out. The radius at that point is 13. So we're going to write 0.13 times omega square, and g is equal to 9.81. So it means omega is going to be 9.81 divided by 0.13 under root. So now let's try to do this. Okay, so this is going to be 9.81 divided by 0.13. So it is 8.7 radians per second shown. Okay. All right. Now, then it says the chord of the mass is mass rotates. So the chord is vertically below C as shown in 1.3, as you can see. Calculate the length of the chord assuming that it obeys Hooke's law. Now, the moment I see this, now I need to, figure out what are the things happening here. First of all, let's look at this. This is the point where this is the case A, right? This is case A, which we did here, right here. And it is when, we have to make the equation. So let's now make the equations. First of all, I'll make the forces. So the weight is down, as you can see. The tension will be up because it's in this position. And obviously the centripetal force has to be towards the center as well. That would mean that centripetal force will be equal to tension minus W. And the reason I'm writing this is because you guys need to understand that this equation, the tension has to be greater than W in order to have resultant force upwards, which means I can say tension is equal to centripetal force plus W. All right. Any questions here, please let me know.
No, sir.
Good. Now let's write this. Now the tension, this tension obviously is equal to the force, which is obeying Hooke's law. And in Hooke's law, we remember that it's equal to, force is equal to kx, where k is the spring constant. Unfortunately, we do not have that. And we need to do something about it. It means we're going to put it right here. So instead of t, I'm going to write kx. Fc is mr omega square plus mg, like that. Okay. Now check this out. Now, because I want k and I know the extension, I don't know the extension really. So to find k, I could find k from this part where they gave in the very first figure, that's 1.1. We have the extension, we have the force, so we can use F equals to kx. F was 5k, and x I could just simply find it as 1.8. So my K would be 5 over 1.8 Newton per centimeter. You just need to remember that these are the units we're looking at, right? So I'm going to write here 5 divided by 1.8 times. Okay, and the extension basically is the original length of this was 13. So now the new length. So what I'm going to do is to find the extension, I'm going to do length minus 13 centimeters. So this is this first part done. All right, so let me just put it a bit like this, so you guys understand better. mv squared over r plus mg. Okay, then let's look at this one. So we don't know the mass, and we can find the mass to the weight, because weight was 5 Newton. So we could say 5 divided by 9.81 would give us the weight. The speed, oh, I had to use, we have m r omega square, sorry. So 5 divided by 9.81. We don't know the radius, because radius has to be equal to the length now. So I can just multiply the length, multiply by, what I'm going to do is, I am going to put, and this length has to be in meters, because the thing is that 9.81 is meters. So I have to multiply 10 raised to minus 2 as well, times omega is 8.7 whole square. So this is done. And obviously, the weight remains the same, which is just 5.0 newtons. Okay, so we have 3 parts done. Now we will try to solve this, obviously, and this is the tricky part. All right, let's try and do this together. So you guys can actually calculate with me, because I make so many mistakes when I'm calculating stuff. So you can help me out if I'm wrong somewhere. So 2.77. 2. So I would like to write it as 2.8. Okay. Just a second, please. Sing, hurry up, please. Okay, never mind. I'll do it anyway. And
Sir, if you've taken L times 10 to the power minus 2 on the right side, shouldn't you also take it on the left side?
no, I don't want to take it on the left side. The reason is that the
You
units
can't
are
do that, can you?
No, I can't do that. The reason is that my K is in Newton per centimeter, and L minus 13 is also in centimeters. Centimeter and centimeter will cancel out, so I don't need to change it. Do you understand?
Yeah, but don't you need to write like times 10 to the power minus 2 outside the brackets?
No, then it would convert it into meter. How will I cancel it? For some reason, now this guy has gone crazy. Wait, let me just open it
No, I
again.
mean like on the right hand side and the left hand side, how can that make sense?
I'll tell you. I'll tell you why I'm doing that.
Yeah, okay.
Okay, I'll tell you now. Okay, the thing is that why I have what? Okay, here it is. Sorry. So the thing is why I have done this like this, because Munib, this is, if I write the units down, so this is why this question is difficult. Newton per centimeter, right? These are the units. Okay. Multiply
Yeah,
by
okay.
centimeter for this. So centimeter and centimeter cancel out. So this side is just units, right? In this
Okay.
part, it is basically newtons and over basically kg, meters per second square. Do you understand? So here's meters. And now on this side, we have to have, this was in centimeters, so I had to change it into meters. So this meters
But
and
how
this,
is it over ms minus 2?
because this is acceleration due to gravity, right? 9.81.
Oh, okay. Okay.
So I need to cancel meter and meter. That's why I had to change it. Do you understand? Originally, this was in centimeter. That's why. You get my point?
No, sir, but how can you compare an L with a centimeter to an L with meter? What?
Because the units cancel out now. If you understand, if I
Yeah.
keep it without minus 2, it would be in centimeter, right? And this would be in
Yeah,
meter
yeah.
second. How will I cancel this? I have to
You
write
don't
this.
need to. You can just rearrange for L, right? Or do you need to cancel out the units?
I need to cancel out the units, because
Can't you
units,
just rearrange for L?
no, if I rearrange, centimeters will be left out, and then you can't subtract meters from centimeters. Do you understand? You need to
No, I
cancel out.
genuinely don't get it.
This is the point of all this. You see, you've read homogeneous equations in AS, right?
Yeah.
So in homogeneous equations, you need to remember that each term has to have only one unit. So this is Newton. These are all forces, right? They have to have units only, newtons, and then we can cancel them out, right? If this side has Newton per centimeter here and centimeter on this side, centimeter and centimeter cancels out. L doesn't really matter then. Do you understand?
Mm-hmm.
And in this side, it is Newton and meter second minus 2. So meter has to be cancelled out somehow with meter, not with centimeter. If I just write L, then it will be in centimeter and then will be carried forward, which will give me a wrong answer altogether. Do you understand?
Okay.
The other is that you also change everything on this side as well. Like you could do this this way. You could write this as 0.018 and then multiply 10 raised to minus 2 here. Then it will be in meters and this will be in meters. Are you happy now?
Yeah. Yeah, now it's better.
Okay, it doesn't really matter. Okay, that's what I'm saying. I'm just teaching you why Newton, you have to just keep, each term must have consistent units. Understood? Now let's do this. Okay,
Okay.
this way we'll get length in meters now. Anyway, so let's do this. So 5 divided by 0.018, right? Times, and this is 2. Oh my goodness. Okay. 2.78, sorry, 278 length. And then this thing should be multiplied with 30, right? Oh no, no. Wait. 10 raised to power minus 2, I also need to multiply that. So this will come out as 2.78, right? L minus, this should multiply by now 30. So this is going to be 36.1. All right, is it clear? Now let's do this. Now on this side, it is 5 divided by 9.81 times 10 raised to power minus 2 times 8.7 squared. So this is 0.386 L plus 5, right? Is that clear? Now let's move things here and there. So 2.78 L minus 0.386 L equals to 5 plus 36.1, right? So let's do this. So this is going to be 2.78 minus 0.0386, 2.74 equals to 5 plus
So it
30.
is 0.386, 0.03
Where?
in the calculator.
5 into 9.81, right? Times 10 raised to
No,
power
no,
minus.
no, 2.78 minus 0.386. That's what I'm saying.
5. Are you sure about that?
So just the second last line, not the whole thing.
It's 36. Which second last? This one?
Yes.
What's wrong in it?
So you put it wrong in the calculator.
This value.
Yeah.
Value is wrong.
No, sir, the L, when you subtract them, it's 2.39.
Acha, okay. You say last line, huh?
So it's second last, not last.
Last line is wrong. Then 0.386, like this. Yeah. So this value is wrong, right? Okay. So 2.394. Is that fine, Gatika?
Yes. Sir.
Okay, 5 plus 36.1. This is going to be, you know, all my notes have my students calculated. I never calculated. That's why I hate calculating. Oh my God.
Here, we can do it for you.
Yeah, it's all right. Let me practice a bit, okay? In my life, I might need maybe someday, you know, my students on this, so I have to do it. So now length will be equal to 41 divided by 2.394. So this is going to be 17.2 centimeters. So this should be the answer. Is that clear, everyone? So the idea behind this is that what I want you to basically learn from this is that the units on each part should be consistent, and obviously the whole solution that
So
we've done.
isn't the unit meter?
No, it will not be in meter. That's what I'm saying. It doesn't really matter what you do. The units cancel
'Cause
out.
then you change it.
The L was in centimeter, right?
No. Sorry.
The L was always in centimeter. We just converted like, this in meters and it cancelled out. Ultimately, you will still get in centimeter because the original L was in centimeter. Do you understand?
Okay, sir.
But so we did convert it to meter. So our final answer should be in meter.
No.
Why?
Because Gatika, this one, when you write 10 raised to power minus 2, right? Let me tell you this. If you look at only this section, do you see this section?
Yes, sir.
Look at this. 5 is in newtons, 9.81 is in meters per second, and you're multiplying length in centimeter with 10 raised to minus 2. Do you agree?
Yes.
Now, now see this. This basically, when you do this, right? Basically, it changes nothing because even if you get it down, right? So you see that it's going to change. And basically, this meter, this when you change it, this becomes meters like this, right? Is that clear? Now, this meter and meter cancels out, and ultimately, it doesn't change a thing because now only newtons are left. Every second, only newtons left, and length just stays length. Do you understand what I'm saying? Whatever it was in centimeters. Do you understand?
So the purpose of putting 10 raised to minus 2 was to cancel the meter?
Yes, that's what I'm trying to explain to you, people.
Okay.
Again, let me just show you. Munib, do you understand now? You see?
No.
So 5 Newton divided by 9.8
So if I
meters.
make if let's suppose I have like 1 centimeter, I write it as 1 times 10 to the power minus 2 meters. So the unit just changes, no? I don't get how the unit did not change.
It does because, Munib, let me
Yeah.
tell you again. The only reason you get confused in this one is that you made me multiply 10 raised to minus 2 here as well. Do you agree?
Yes. So now on both
All right.
sides we got meter, and then the final answer should be meter.
Yeah, but with this whole thing, is it like, can you see that this minus 2 and this minus 2 really just cancels out anyway? It doesn't really matter, right? Because the thing is that ultimately you also made me change this one, right? Because this has to be in meters then to cancel out meters. So the point is that 5 over 1.8 was in centimeter, right? The only way you change this as meter as this one, and these whole things as meter as well, like 10 raised to minus 2. Understood? So this was in meters, and now this one was also made in meters. So this and this cancels out, that and that cancels out. So whatever the original units of L and 13 were, that stay the same. That's the point. It's the rule for homogeneous equations that whenever you're looking at any equation in the world, remember, any equation in the world, every part of the equation just remains the same. All right, Munib?
Sir, when you multiplied when you multiplied 5 over 0.018 with 13, did you multiply it with 13 or 13 times 10 to the power minus 2?
10 to power minus 2.
Yeah, then how did it cancel out?
Because 5 newtons over 0.018 meter multiplied by 13 times 10 raised to minus 2 meters, they cancel out. That's fine.
Oh, okay. Gotcha.
Do you understand? That's fine.
Yeah, I get the canceling out part, but I don't get why L is in centimeter. That's the thing. I
Okay.
have no clue why.
All
Okay,
right.
anyways.
Okay, just try it on your own. All right, today. See if you can get in 0.172. You can get in 172, right?
Okay, I'll try.
Try, because ultimately this answer is the correct answer. You can try, and then you can come back to me and see, okay, why it is not coming in meters. Maybe you can get it in meters, right? All right, Munib. That's fine.
Yes, sir. Yes, sir.
Okay, so this is what I want to, do with you. The homework that I want to assign to you now would be basically, I signed this one yesterday. I would like you guys to do this one as well now. Okay. So this chapter is only this much. It's very small. You can complete the whole sheet, and then you can get back to me when we are discussing this. Okay.
Sir, in one of the questions you gave yesterday, there was a part about simple harmonic motion.
Okay, you can just skip it for now. Okay. If you know it, obviously you know it. You've done the whole syllabus once, so you can also solve it if you want to. Okay.
Yes, sir. Okay.
All right. Very good. Okay. Now, well, I was thinking if we, all right, all right. I was thinking, I'll tell you, Munib, I'll tell you something very important. Okay, Munib, right now. I get it why you're so frantic about it. So, Munib, if you write the equation, I get your point why you're so confused. Let me do it for the meter one, okay? Munib, can we write it like this? 5
Yes, sir.
divided by 0.018 multiplied by
Mm-hmm.
length. Let's assume length is in meters right now. Let's assume, okay?
Mm-hmm.
If length is in meters, then we should subtract 0.13 from it in meters. You agree?
Yeah.
And then on this side, we are just assuming length in meters. Okay. Then on the other side,
Okay.
5 over 9.81 times, we will only multiply length, right? Not minus 2, because it's in meters now. Do you understand?
Yeah.
Okay. Multiply by 8.7 whole square and plus 5 newtons. Agreed? Okay. Now,
Yeah.
let's do it. Now, Anusha and Gatika will help us. 5 divided by 0.018. And this is going to be 278 length minus 5 divided by 0.018 times 0.13. So this is going to be 36.11, right? On this side, it is going to be 5 divided by 9.81 times 8.7.
Sir, I think you made a mistake.
Where?
Sir, could you do 5 over 0.018 real quick?
This one?
Any, sir, just in the calculator. Just could you write 5 divided by 0.018? That's 277. You've written 2.78.
No, I've written 278. There's no point.
No, not on the right hand side, sir.
Because that was 10 raised to minus 2 with it too at that
Oh,
time.
okay. You considered that. Okay.
Right? Don't look at the right side.
Yeah.
Look at the left side.
Yeah, okay.
5 divided by 9.81 times 8.7 whole square, right? This comes
Yeah.
as 38.6 length plus 5.0. Agreed? Now.
Yep.
So 278 length minus 38.6 length equals to 5 plus 36.11, right? So on the left side, 278 plus 38.6 is going to be 316.6.
Sir, minus.
I have to minus it. Oh, sorry, Gatika. Thank you, Gatika. Gatika saves the day. Okay, so this is going to be 239.4 L, and on the other side is going to be 5 plus 36.11, right? 41.11, right? And now,
Yeah.
if I want to find length, it's going to be 41.11 divided by 239.4. What do you get?
0.172
meters, which is
meter.
equal. Now,
Yep.
do you agree what I'm saying now?
Yeah. Now it's fine. Yeah.
What I'm saying is that 10 raised to minus 2 multiplying on both sides doesn't matter. If you are able to cancel the meters on each side, whatever you assume in the first place, it is going to come out as the same. Understood?
Yes, sir.
Now, happy?
Yep.
Okay, good.
Yes.
Now, copy this. And now you need to finish this worksheet. Okay, complete this and submit it. Okay, because the chapter is finished. And now from tomorrow onwards, we're going to start gravitation. So within this week, on till
Where do we
Friday,
submit it, sir?
Friday.
On Google Classroom.
Yeah.
Okay.
Sir,
Good.
do these type of questions come frequently in the paper?
Yes, obviously. All type of question comes frequently. I'm just trying to help you, solve those questions which are very critical. Other ones, how many questions I've given you? All these questions came, and I just wanted you, because these are simple ones, so I wanted you to practice with them, right? Get it? Okay. Now, so I will see you tomorrow, same time then. Have a nice day. Bye.
So इसका आंसर क्या है? Why increasing
Alright, sir,
speed
bye.
requires greater centripetal
I have
force?
given it to you. Within the questions, I've given it to you. This is homework.
Okay.
Homework. I have given it to you. I have explained it to you here. Sorry, this part. Okay.
Fine.
This is like very similar. So I want you to write it. Okay. All right. See you guys then. Have a nice day. Bye.
Bye, sir.
Bye, sir.
You too have.
Bye, sir.
Bye, sir.
नहीं खाने यार मैंने नहीं मैं चीजें खाता ये वाली